Hello. In this video, we're going to introduce inequalities, and in particular, one-dimensional inequalities. And all that means is we're looking at inequalities on a number line. So first, when we're thinking about inequalities, it's saying it's some numbers that are either greater than or less than or maybe equal to at some points. So for this first one, x is greater than 4 is saying all of the numbers that are greater than 4. So if we think about it on our number line, it's saying all of the numbers on this side. And we wouldn't include 4. So we'll signify that as either an open circle or sometimes textbooks and websites will use just a parentheses. Which is nice because if we're going to put this in an interval notation, we would say it's the numbers from 4 to infinity. And we would use parentheses to indicate that we're not including 4. So, in contrast, if I want to say all of the numbers that are less than and including 4, that would be all of the numbers on the left of 4. And to show that I'm including 4, I would have a closed circle. Or I could have a bracket. They mean the same thing. And if I'm writing this in interval notation, I would say it's my numbers from 4 to negative infinity. But normally we write from negative to positive. So I'd write it as from negative infinity to 4. And those are our basic inequalities. So now we do have compound inequalities. And what these are two or more inequalities kind of put together to mean one set of numbers. So if I graph this first one, it's the x values between negative 2 and 3. So let's say I go on here. I don't see that it's equal to, so I'll use open circles. And it's saying the values in between, so it's trying to specify these values in between. Now, another way to think about that is it would be the numbers that are both less than 3 and greater than negative 2. And that's where this compound inequality is coming from. It's this combination. It's where both of them are true, where both of these values lie. So now our final example gives us a compound inequality that's not combined together. And in this case, we have our two numbers. And this or is saying that it can be in either of these two intervals. We have including negative 4 and less, or we have not including 6 and greater than it. So it can be in either or. And so again, we see that this compound inequality is talking about two intervals. And if we're going to talk about this in interval notation, it would be the numbers from negative infinity to negative 4, including it, 6 to infinity, and then I'd use this union, or this big U, to say that it's both of these together. So thinking about compound inequalities, we have two kind of special cases. If I have a compound inequality, if there is no solution, that would mean I was looking for some overlap and I didn't find any. So for example, if I have x is greater than or equal to 3, and x is less than or equal to negative 1. If I graph these, x is less than or equal to negative 1, and x is greater than or equal to 3. And if I'm looking for this overlap, I can see very clearly I don't have any. So there would be no solution. There is no number that's both greater than 3 and less than negative 1. So obviously, in this case, it was very clear that we had no solution. But if we're trying to solve a compound inequality, it's sometimes the case that it falls out that we see something like this. So it's just something to keep in mind. Now, what would it mean for all real numbers to be the solution? Well, what if we had the same kind of situation, but we said that it was x is less than or equal to 3, or, and I'll use a different color, x is greater than or equal to negative 1. So in this case, I have my number line. I have my 2 points, negative 1 and 3. So now in one case, I'm looking at all of the numbers that are less than 3. And then in the other case, I'm looking at all of the numbers that are greater than or equal to negative 1. And you can see that I've now colored in the entire number line. So I can describe all numbers as either smaller than 3 or greater than or equal to negative 1. And so again, when we're solving them, we want to keep these two special cases in mind. We do want to try to graph them and see if there's no overlap or if there's all of the overlap. And that's everything that we need to know about one-dimensional inequalities.